Peter Henke, Vice Chair at Vascular Discovery 2024. And I'm very happy and honored to introduce Dr. Arany, who gave a standing talk this morning related to fat metabolism in the endothelium and its connection to the metabolic syndrome, which is a huge epidemiologic health issue in the US and the world. So welcome.
Thank you.
And if you could, you kind of told two stories, one a little shorter, one a little more a little longer. And if you could kind of recapitulate kind of your main findings with or main message with the cardiomyopathy and fatty acid not getting into the cell, and then kind of the opposite with the other endothelial beds accumulating too much lipoprotein.
Yeah, so our story really is about how the vascular bed and specifically the endothelium handles lipids or handles fats. And our point of departure was the observation, the really interesting observation that in failing human hearts based on human samples that we have had the honor and the privilege of having access to from our collaborations with Ken Margulies, who's next door to us. These are post-transplant human hearts, and they're compared to discarded donors, so we have a control group. And when you look in these hearts, what you see is that the fatty acid flux, or the fatty acids in these tissues, is dramatically reduced. And so the conclusion there is that there's an inability somehow in heart failure for fats to enter the heart and enter the cardiomyocytes. And that has led us to ask the question, generally speaking, of how fats get transported into the cardiomyocyte and into the heart. And that's a question that actually is surprisingly poorly addressed in the field. And there's actually a major hurdle to getting from the lumen of the vessel, which is where the fats are transported in lipoprotein particles or bound to albumin if they're not esterified. They have to get all the way into the cardiomyocyte. And to do that, they have to cross the endothelial layer. And so that is the sort of the initial heart failure observations have led us to really ask, how do fats get across the endothelial layer? It's a barrier. It's a barrier, and how does that happen?
Yeah.
And that was the sort of impetus for that, then led to the second half.
And then, so with that, any targets, translational targets yet identified to improve that process? And then maybe a little bit differently related, but it seems like, GLP-1 inhibitors can cure everything, and I know they have a beneficial effect on heart failure. Any interactions there?
Yeah, that's a great question. We haven't really looked at that directly. The mechanisms by which fats get transported are still very murky. There's a dominant player that everyone talks about, which is a molecule called CD36 that can bind to fats and internalize them. And there's pretty decent evidence that they're at play. They're not the only player. There are people walking around who are totally deficient for CD36, and they're okay. There's a whole group of people in Japan that are like that. So clearly, it's not the only player. Yeah. And so honestly, we don't know yet. That's why we're so interested in this topic. And how the GLP-1s play into this is also murky, and it's confounded, of course, by the effects on body weight and adiposity and circulating triglycerides and circulating fats. So it's a complex picture, and we're just beginning to get into this.
That's awesome. And unfortunately, a lot of heart failure patients.
A lot of heart failure patients, and probably more to come.
Yep. Yeah. Then kind of your second portion of your talk was really looking at the accumulation of these lipid droplets in the endothelium. If you could kind of recapitulate the main message there.
Yes, certainly. So that was a bit of a side track in some ways, because our point of departure is how do fats get across the endothelium. And then what we realized, in part educated by a really interesting study by Bill Sessa, who was at Yale at the time, he's now at Pfizer, demonstrating that when lipids, as they go across the endothelial layer, will actually transiently accumulate in the triglyceride pool. This is not intuitive. When you have a free fat, if you as a cell wanted to take, palmitate and go from the lumen to the cardiomyocyte, there's no real intuitive reason why you would want to first esterify it into a triglyceride and then de-esterify it back to the, but that's what the cell does. And we don't really understand why the cell does that. But that means that in certain contexts, for example, a high-fat diet, we find that these lipid droplets that have the triglyceride pool accumulate, and you have more and more of these because you're basically flooding the system with fat. And what our study found out, and this was led by Boa Kim, who's a spectacular postdoc who now has her own lab at University of North Carolina. I recommend following her career. So what she found is that these accumulated lipid droplets in the endothelium actually have an effect on endothelial biology. And the most prominent one is a reduction in nitric oxide synthesis from eNOS. And that's a well-established pathway involved in blood pressure regulation. So the sort of observation in the end is that when you accumulate these lipid droplets in the endothelium from too much fat, your blood pressure goes up.
Mm-hmm.
This is all, of course, what we see in the mouse model. But that's extremely interesting because, as you were alluding to, blood pressure elevation travels with various other aspects of the metabolic syndrome: hypertriglyceridemia, obesity, diabetes. These things travel together, and we don't totally understand why they travel together. And I think this is insight into at least a little bit of it, explaining why hypertriglyceridemia and obesity predispose to hypertension or high blood pressure. So we think it's part of it is accumulation of this lipid droplet pool in the endothelium.
Oh, that's fascinating. And again, you're starting to establish this connection for a very common syndrome that has only increased over the last couple decades.
That's right.
One thing, are all fats the same? For example, olive oil seems to be protective. There was a recent article that it decreases Alzheimer's, and it has, generally the Mediterranean diet is healthy and people live longer being on that.
Yes.
How does that play into the accumulation?
Yeah, that's a good question. We haven't done a lot of studies to look at that. That's a really good question. But at first blush, it doesn't seem to impact this pathway, which is to say that if we do the same thing with olive oil gavage, or a high-fat diet, which is more rich in palmitate, for example, we see the same accumulation of lipid droplets and the same impact on. So the transport is probably similar, I think, on the different fats. But I'm sure there will be differences when you look closely.
And from your talk too, you identified one of the pro-inflammatory MCP1, which causes monocytes to accumulate, and you mentioned that you didn't see that you saw a large accumulation of monocyte macrophages or inflammatory cell aggregation, but you did identify seemingly a target that may be downstream from the eNOS pathway and raising blood pressure. Is that something that's targetable pharmaceutically, or is that way down the road?
Well, the short answer is it's way down the road.
Okay.
Yes. I think that what we've uncovered is an explanation for a long-standing observation, or at least a partial explanation. I'm actually not 100% sure that it's going to translate into new blood pressure therapy. I think we have a lot of therapies already for blood pressure. I'm not sure we need a new one unless it was some sort of magic bullet. So we may or may not go down that road. But I'm a firm believer in understanding biology for its own sake, because you never really know where it's going to lead.
Right.
I always give the example of, if somebody wasn't studying worms, we wouldn't have RNAi, and if somebody wasn't studying bugs, we wouldn't have CRISPR. So
good point.
I think studying biology for its own sake is good, but who knows?
Well, thanks so much. Fascinating talk, and hopefully the folks viewing this will get a little bit of what we heard this morning.
My pleasure.
Thanks so much.
Thank you very much.